Hi there, my name's Andrew Brown. Welcome to Real-Time Music and Sound in Pure Data. In this video we're going to be looking at arranging sequences over time. If we're working in a digital audio workstation, which often look like this, which have a timeline, we would have sequences that we could position in time and they could play and repeat, start and stop at certain times. We often want to do that in Pure Data as well, but there's no explicit timeline. So what we're going to be looking at is how to start and stop sequences at certain times over time so we can arrange a song. The basis for all sequences and for time in Pure Data is the metro object. So let's start with that. We're going to be working at 120 beats per minute, and I've chosen half a beat sort of time periods just to make it go double time. We can put a toggle to start that. That of course will output a range of bangs, and for all of our sequences, as we've seen in previous videos, we'll use an incrementer to count the number of bangs or the number of steps that we take. And that number just keeps increasing as we play. We can send a value to the float to reset it to a certain number, so that will take it back to 0, for example. When we're working with a sequencer, we usually want to have it repeating a certain number of steps, so we use the modulo command to make it cycle between 0 and the maximum number specified. And we can show that conveniently with not an H slider, with an H radio button, and that's a visualization of our sequence running. So what we want to also be able to do is to run a number of sequences. So if we had, for example, a second sequence, we could of course simply connect that up and they would run in series. But what we were looking to do is to start this second sequence at a later time, and so we're going to need to do a little bit of processing before that. So there are a few techniques that we could use. One would be to look for a particular number and do something at that time. So for example, if I get a toggle, I'll put that. So then if we connect the number to that equals or equivalent, I'll reset it. When we get to 16, the toggle will be set, and that could trigger something. Let me just do that again. It goes past very fast because as soon as it gets to 17, the toggle goes off again. So it's kind of okay, but not super useful. So if, for example, instead of that we use something which was like greater than or equal to 16, then it would turn the toggle on and it would stay on whilst we were past 16, which is a little bit more useful as we go. What could also be handy in relation to this would be to have a spigot, which is a gate in PD, started, closed, and we could make the toggle open and close that gate. We could pass the number also to the gate and then on. If we go back turn that off, go back to the beginning. So you can see now that until it gets to 16 it stops. I'll do that again, so that it pauses that from the beginning until we get to 16, and then after we get to 16 it opens it up. It's quite a bit of infrastructure here, and there's possibly a slightly more convenient way of doing all of that using an expression box. Oops, expression. So we can put some logic in here. We can say if the input is greater than or equal to 16, then send the input out. Otherwise we can send some flag that indicates that we're not yet there, -1 in this case. We can then select for -1, and if we see a -1 we'll do nothing. If we get anything else we'll send it through. Then we can connect that up, so we're passing through this value. If we go back to 0, it's not playing until we get to 16, and then it starts. The nice thing about this too is that we can extend the logic, so we can say if it's greater than or less than 16, and also if the input number is less than, let's say, we know we can even do some math here to make our thing easier. 8 times 4, because we know it's an 8-step sequence, we can 4 cycles through. So what this will do is you can see that it's stopped then. If we start it again, it will wait for us to get to 16 as the count, and then it will start playing, and as soon as it gets twice through it will stop again. So this way we can put in all sorts of logic for starting and stopping. In essence, this is the process for controlling these additional sequences, and you can create as many as you want and give them each a different thing. Control them from the one clock and they'll all stay in sync and start and stop at different times. If that's all you want out of this video, then pause here. What I'll do is just go on to make it make a little bit of a noise, because at the moment it's not all that interesting musically, but this doesn't add anything to the logic that we've got here. So let's create a small array and a little synthesizer to play that array. So I'm going to put a new array. I'm going to call this array sequence 1. It's going to have 8 steps. I need to change a few properties of that array. It's ranging from 1 to 8, that's fine. The size can be 120. The values can go from, say, we can use MIDI pitches, 120 down to 20. Doesn't need to be all that high, so we can do that. And so there we've got a sequence. And we need to be able to read from that array, so we can get stuff from sequence 1 at the index that our counter is at, and if we put a number box there we can see that that's spitting out values, and I can change those manually by drawing a line, a sequence, kind of a bit of a random sequence. If I wanted to quantize that so that we only get pitches within a particular scale, I can do a pitch quantize. There's an earlier video on pitch quantize, so I won't go into the details of that right now. And I've got an abstraction which will do that pitch quantize for us. We just need to pass it in a pitch set. So we can just do it like a minor pentatonic. Okay, phone rang. So we can just do a minor pentatonic, connect that up, bang it. We can bang it, and then we can see that the number coming out will be slightly different. Okay, so far so good. And to get that to a frequency, to play a synthesizer, we can do a MIDI to frequency command like so. So now we need a bit of a sound engine to make a noise. So let's create a simple synthesizer. We'll start with a phaser. Because that's unipolar, we need to multiply it by 2. That's the tilde. And we need to add 1 just to make it bipolar. That's going to of course be quite bright, so we'll use a voltage control filter. There we need to specify the frequency of this phaser, which is going to come from here, and we'll use the same frequency to specify the cutoff of the filter. And then we can do a bit of an amp gain control and go out to a DAC. Alright, of course we've got this sustain because we don't have any amplitude envelope, so we can very quickly add an amplitude envelope using a V-line. Let's say go to 0.5 volume, take 10 milliseconds to do that, go to 0, take 400 milliseconds to get to there, and wait a little bit before you start your release. Connect that up. Nice. We need to take that out before that will work. And we just need to trigger that somehow. It's not super critical where that comes from. But of course we've got this second sequence, so what we can do is copy all of that and use it again for a second sequence. It's getting a little bit crammed in here, that's okay, we'll make this work. We'll change this sequence to be sequence number 2, and everything else should be pretty right, except we need to make sure we read from sequence number 2, and we can put another sequence, draw a sequence in there. Alright, so if we reset our counter to 0 and restart, then the first sequence will play. After 2 cycles, the second sequence will come in, will play for 2 cycles, and then stop. So there you have controlling sequences over time. The big message from this video, of course, was around using this expression or some other expression to see when counts get to the point where you want to trigger a sequence and start and stop it. And you can do that as many times as you need to start and stop sequences across your entire track. I'll see you in another video.